So far we have read the drawbacks in the Rutherford's model, and today we will discuss the postulates of Bohr's model. Now, in order to explain the drawbacks, in order to overcome the drawbacks of model, backs of Rutherford's model. In order to overcome the drawbacks of Rutherford's model and explain the line spectrum of hydrogen, Bohr in 1913 gave the model. That model is known as Bohr's model of atom. Now, postulates of the model are, we will study its postulates. Number first, atom consists of heavily positively charged nucleus, in the center. Now, first postulate is atom consists of heavily positively charged nucleus in the center, surrounded by electrons. These electrons revolve around the nucleus. These revolve around the nucleus. Now, here you have to keep in mind, atom consists of the heavy positive charged nucleus in the center, surrounded by the electrons, and these electrons revolve around the nucleus in certain selected circular paths having fixed radius and energy. This is the main point. These electrons revolve around the nucleus in certain circular paths have a fixed radius and energy. These are called energy levels, or shells, designated as 1, 2, 3, 4, so on, or K, L, M, N shell. These electrons revolve around the nucleus in certain selected circular paths having fixed radius and energy. These are called energy levels, or designated as 1, 2, 3, 4, or K, L, M, N shells. Now, that means This is the electron, this is the nucleus. For example, electrons revolve around the nucleus in certain, these are the shells. This is the first shell, this is the second shell, this is the third shell. And certain circular paths called the energy shells or the energy levels. Number 7 postulate, the energy of electron, shells or orbit जो बोल रहे थे, in an orbit does not change with time. The energy of electron in an orbit does not change with time. That is, as long as electron remains in a particular orbit, as long as electron remains in a particular orbit, it does not lose. It does not lose or gain energy. That is, energy of the electron in the orbit is fixed. That is, these are called energy states. The energy of electron in an orbit does not change with time. That is, as long as electron remains in a particular orbit, it does not lose or gain energy. That means energy of the electron in an orbit is fixed. These are called energy states or stationary states. Number 3rd postulate is only those orbitals are permitted. Keep it in mind. This is the important postulate. Only those orbitals are permitted in which angular momentum of electron is whole number integral multiple of h by 2 pi, h by pi is whole number multiple of h by 2 pi. That means only those orbitals, since electron revolves in circular path, it has its angular momentum. That is equal to mass into velocity into radius. So mvr is equal to lh by 2 pi. That is, angular moment of electron should be integral value. If it is first orbit, at the first orbit then mvr is equal to h by 2 pi. Second orbit, mvr is an energy level, it is h by pi. Third orbit, mvr is equal to 3h by 2 pi, and so on. that is only those orbits are permitted in which angular momentum of electron is whole number multiple of h by 2 pi. Fourth postulate, ordinarily an electron does not lose or gain energy. Does not lose or gain energy. When energy is supplied to an electron, it absorbs a fixed packet quantum of energy, jumps to the higher energy level. For example, this is the nucleus, this is the electron, and this is the second shell. Now, when energy is supplied to the electron, energy is supplied to the electron, it jumps to the higher energy level. It jumps to the higher energy level. This first, this second, it jumps to the higher energy level. Now this energy level, when the electron is in its own energy level, it is called a ground state. When it jumps to the higher energy level, it is called excited state. So that is called excited state. It jumps back and emits the amount of energy, the same amount of energy. For example, if it is energy state E1 and it is E2, so when it comes back, then del E is equal to E2 minus E1. So it comes back, E2 and E1 energy is emitted, same amount, this energy difference between the two levels, it is emitted. So del E is equal to H nu, you know it. So del E is equal to H C by lambda, or lambda is equal to del E by HC. So del energy, that is fixed and this is fixed. So it emits a definite quantum of energy. It emits a definite amount of energy which it absorbs, it emits back from excited state to the ground state. So a fixed wavelength is given which appears in form of the line spectrum. Again, when the energy is supplied to electron, when the electron is present in its own orbit, this is called the ground state. But when energy is supplied, it jumps to higher energy level, that is called excited state. And when it emits the back, it comes back, it emits the same amount of energy which has a definite wavelength which comes to on the spectrum, that is the line spectrum. This is the Niels Bohr's model or postulates of Niels Bohr's model.